Hello, everybody. Welcome to this webinar hosted today by Redgate Software. My name is Ryan Booz. I'm an advocate with Redgate, specifically focusing a lot of my time on Postgres and how we can both help the community in understanding with webinars like this and other opportunities, and in how we are increasing the usefulness of our tools across multiple databases, of which Postgres is one that's getting a lot of attention, and henceforth why we have decided, these are some really useful topics to cover. Now, today's topic is the second in a series. It's the 10 key differences between Postgres and SQL Server. Now, I will tell you, 10 is a number far too low, and I'll explain that in just a minute. There are a lot of similarities, but those little differences along the way make all the difference in understanding how the knowledge you have in something like SQL Server can apply as you begin to use Postgres. The webinar series, again, this is a little bit about me. You can find me on Twitter, LinkedIn, a blog that I do a lot more blogging at these days, specifically around Postgres most of the time. We also lead something similar to, I've helped to start within the Postgres community, something called PG SQL Friday, which is kind of analogous, really taken from the idea of T-SQL Tuesday. So it's a monthly blog event that anyone can join. Someone hosts the event, sets up a topic, and then anyone can write about that topic. And sometimes you'll find some streaming that I will do, or just some videos recorded around Postgres and other things on YouTube as well. So please feel free to reach out. I love talking about Postgres, love talking about this community, particularly those that are coming from a SQL family and SQL Server background. So this is the second in the series. The first one we did last month. You can go back and watch that. It was a high-level overview about Postgres and kind of where things stand in 2023. It's a good primer to this. You're not in any way required to have seen that, but it might be helpful just to get a little bit better lay of the land. So you're welcome to go sign up for it, and you can watch the recorded session at the URL on your screen. This is where the series is going. We are today talking about these 10 key differences. Next month, I'll be showing you how to get started actually using a little bit of Postgres, setting it up very briefly, a couple ways that you can set it up, how to connect, a couple of the tools you can use so that you can feel a little bit more confident in getting started. And then in July, Grant, who many of you know, will actually be talking about some of his journey, some of the ways that he's used his skills from SQL Server coming over to Postgres. And just to remind you a couple housekeeping things. So these sessions are recorded. So if you want to go back and watch it again, you want to understand, maybe a piece you missed or just need to dig into, please, you will be notified of that and you will be able to see this again. And as we go, if you have questions, please put them in the question box, and the team here at Redgate will feed them to me. We'll probably do most of that at the end. There may be one or two spots that if we've gone for a bit and the team is letting me know there's some questions coming in, I'll try and pause to answer some of those as we go. But please, it'd be great to have some of your questions just to understand where you are at in your journey towards Postgres. So here's the agenda. And when I said 10 key differences, what that really means, because it's such a broad topic, is it's going to be 10 kind of area topics. And I'm going to very quickly talk about some of those things as someone that spent a couple of years moving from SQL Server back into Postgres. Those things that I knew I could do, I just didn't know exactly what they were called or how to go about doing them. And so that's really the idea today, is to very quickly work through some of these. None of this is going to be a deep dive, but my hope is that it's a moment for you to say, hey, I'm hearing this term, I'm hearing this thing, and I remember in that webinar we talked about it, and there's this explanation of what that related to in SQL Server. And so that's the goal. And again, I know that this is a pretty big topic. It's kind of coming along thinking this won't be too bad. And then the fire hoses gets sent at you and you are surprised and knocked to the ground, wondering what you're going to do with all this information. So the goal really is to try and help you get started, just making some of those correlations and relationships. So let's go ahead and get started with section 1. These are just ideas of some high-level feature comparisons between Postgres and SQL Server. Now, I've updated these slides recently with MySQL, partially because of various conferences I've been talking at, being able to share some of this information. Not everyone in the room is just SQL Server. I recognize this webinar is specifically about that. But, just to understand across some of the major databases, how these things work together. So in the previous webinar, one of the things I mentioned of why Postgres in 2023, why now, it's an older, it's a database that's been around since the mid 90s and actually even before that. And I highlighted one of the key differences in Postgres is that it is an extensible database. You can add extensions, you can create your own extensions, and hook into multiple processes within the database to actually modify how it works. So the core database that you use can be extended to do some new things, something that's not possible with other databases that we use, specifically SQL Server. This is really one of the reasons why Postgres has gained so much attention and a lot of unique capability that are bringing people into the software. So that's one of the first things to recognize. In fact, when we talk about, how big this can get, two of the extensions that I point to often, one is called Citus. It was from a company called Citus Data, which was acquired by Microsoft a couple of years ago now. And actually the Citus extension, taking core Postgres and adding an extension into it to get more functionality, is what drives Azure Cosmos DB for Postgres. It's this horizontally scalable Postgres option, and it's most of that work is done through something that's installed on top of, in addition to the core Postgres code. So nothing had to be forked and modified of Postgres itself. So really powerful. Timescale is a company I used to work for. It's a time series database. Now they did just change their logo about less than a week ago in a rebrand. So if you see this logo that is Timescale, they also are an extension-based Postgres database, which does some really neat stuff for time series data with partitioning and automatically materialized roll-up data, things like that. So you can do a lot of really interesting things with extensions, and it really has contributed to the growth of Postgres. As far as data types, Postgres has also gained a lot of interest because a number of years ago, they added a specific JSON field data type, not just a text field that's kind of treated like JSON, and a JSON B field, a binary representation. And what's really unique about the way that Postgres does this is they added indexes on top of that data type. So you can actually index all of the components of the JSON document and query specific nodes and parts and what have you. So it really makes it and for many use cases, a pretty performant database for doing JSON-like queries and ETL process, things like that. So it's really a native support of an actual data type that goes beyond simply a text field that stores some JSON and what have you. Now, Postgres also among these three major databases in SQL Server. I say two here. That might be, especially with SQL Server 2022, there's some new additions coming that might allow you to talk about indexes a little differently. But out of the box, Postgres comes with at least 6 different index types. We don't just have B-tree, but we also have things like a hash index, and we have a geospatial index. We have things like you can install an extension for a trigram index, which is really interesting for searching textual fields for like in a search box. So there's a lot of opportunities in the way that data can be indexed within Postgres. It's really not possible in other databases, either in the core system or through extensions. This has become, again, a really interesting way in enabling use cases that really aren't possible without a lot of work in some of the other database systems. Now, all of the databases do support native partitioning. Postgres, up until version 10, didn't have what we would consider native partitioning. You had to do it through something called table inheritance, had to use triggers, do some other things. Starting with Postgres 10 and really becoming much more solid and usable in Postgres 11, which was now 5 or 6 years ago, we have declarative native partitioning. It's actually, in some ways, a little bit easier to set up and do than in SQL Server. And it works very, very well and very efficiently. And it's as you would use partitioning for other reasons, both in querying data and pruning data over time. All of those use cases do exist. Then functions and procedures. The unique thing here is that we can use different languages in SQL Server with the CLR. Multiple language support in MySQL does not exist. Postgres, any language that is available on the server, you can use. I say any, it's really just about any language you could think of. There's probably a Postgres extension or add-on that allows you to run those store procedures and functions in that language, whether it be Python, Perl, C, Rust just got released in the last few weeks and just was announced last week on AWS as officially supported language for your functions and stored procedures and so forth. So really a broad language support that doesn't require as much effort and compilation and installation into the server like you would need to do with CLR. And then one of the last things that's unique about Postgres is this idea of transactional DDL. And so because of how Postgres does multi-version concurrency control, is unique among the databases in that you can actually begin transactions, do destructive, maybe destructive or additional DDL work, and roll that back absent of other transactions. And so it does allow a lot of unique ways for you to maybe practice migration, check things about data, things of that nature. So it's a really unique opportunity that if you've never had, the wheels start to spin of how that could be helpful for some of the tasks, testing things, understanding what might change in the background without actually doing some destructive stuff within the database. Now, a couple quick things that Postgres doesn't have, and I put these in here because we have gotten so used to them as SQL Server developers, and it does tend to surprise us when they don't exist. The first one that I always point out is query hints. So Postgres has been developed over the last, as I said, 25 plus years in the form that we currently know it today. And that entire time, it's developed by an open source community of committed, developers into this code base. And there's a common belief within that code base, within that core group, that if the query planner isn't doing a good job, then there additional work needs to be done to improve the query planner rather than add more and more hints to tune what the query planner would normally do. Whatever that means, there are now extensions that will help you write some query hints into your plans if need be. So there are ways around it, but out of the box, it's not something that you can just do in a query. You can't say degree of parallelism, for instance. You can't, heaven forbid, say no lock. Those things just don't exist within Postgres to do within your queries. We don't have a visual query explainer. So query plans within Postgres are a text-based query plan. I actually took the screenshot out of here because I figured too many slides and we'd move on. Just to say that there are opportunities for this. Some of the tooling that you will use visually, whether it's PG Admin, even though it's not a tool that I tend to use, it does have some similarities in how it tries to present a visual plan. There are online tools, but out of the box, when you do what we call explain, which is a way of getting the query plan, you will get a textual query plan that you'll have to begin to understand how to read. And again, there's lots of help online on how to do that, and probably something we'll provide some more information on as we go, either through this webinar series or in additional work on Simple Talk and places like that. And then Postgres does not have a query cache or monitor. So, something like query store. When a query is compiled in SQL Server, the plan is stored for later lookup for some period of time to reduce the impact of that query plan. Postgres does not have something like that. You can prepare a plan within a transaction, but when the transaction is done, the plan is no longer reused. And so, again, that comes back to this mentality that the plan should be fast and efficient to come up with. The code should be able to do that regardless, and caching might produce more problems than benefit at some time. So we don't have the problem, for instance, of parameter sniffing generally in Postgres, because we're not using an old plan that might result in something new, even though the plan looks the same. But again, just to know that those things don't exist within Postgres. And the last one is a job scheduler. By default, Postgres does not have any job scheduler built in that you can create jobs and have it run for you like the SQL Server agent. And so it's something that you have to think about. If you are doing lots of work within the server through agent jobs, you'll need to find some other way to do it. Now, there are, again, this shouldn't be a surprise, there are extensions that will do the work for you. Things like PG cron. I believe one is PG timetable. Even something like timescale, because those extensions have an internal scheduler, timescale a number of years ago, if you happen to be using that extension, has a built-in scheduler that you can create jobs with and use that scheduler as your job engine. It's something you just have to know and you have to think about as you would make some transition over to Postgres, depending on the jobs that you're doing. So that's high-level overview of some differences within the technologies themselves. I could have made that list alone could be the webinar. There are a lot of little things here and there, but it's a good quick start just so you recognize, why isn't this query plan being reused? Well, because there's no query store for a prepared query plan, just to recognize that. So let's talk about terminology. This is going to be pretty quick. There's maybe 11 or 12 slides here, just things to know as you're talking about Postgres. The first is that we would generally say you install SQL Server on a computer, and we are logging into the instance. You can have multiple instances of SQL Server, the process running on a server, multiple versions, releases, or multiple instances of one version. Each of them is self-contained. That's a server and so forth. In Postgres, years ago, it got called a cluster. There is a reason for that, but it is still the terminology you'll hear or see in documentation, even though as far as we are concerned, it's the instance. So I can have multiple Postgres instances called clusters on one computer. It does not mean that it is a network of Postgres instances clustered together. Just to recognize that, something to know. We talk about roles in Postgres, not users. Roles are both users and groups. There's actually a series I just finished on Simple Talk, which we can provide the link to later, that talked about what these roles, how they work within Postgres and the way that they are maintained. So for instance, a role that is allowed to log in, we generally refer to as a user, and a role that is not allowed to log in, we generally refer to as a group. And there are ways to use them, inherit permissions and privileges and so forth. But again, just to see as you look into documentation and so forth. The idea of the transaction log is essentially what we call the write-ahead log. So it's the place where transactional data goes first to make sure that it is recorded before it's flushed to disk so that we have an ACID-compliant database. And so you won't see, we'll talk a lot about transactions, but you won't see anything about a transaction log in Postgres. You will hear, we call it either WAL, W-A-L, or the write-ahead log. And so lots of conversation about how that works, log shipping to do replication, all of those things are referring to the write-ahead log. And then when I first came to Postgres, I was, the word tuple or tuple, depending how you say it, was thrown around everywhere. And I was used to that in like the Python programming language. But I just kept getting confused. Is there something special about a tuple as opposed to just a row of data? And I have come to learn that essentially, the word tuple in this context means essentially the schema of the row. So the data types of the columns and so forth, when you put that all together, the representation of the row is the tuple. It still is just a row of data. So you'll more and more you'll hear see documentation and blogs and talks talk about just rows of data in a table, but you, almost interchangeably, people in documentation will simply say tuples of data. They really are the same thing. One just has more of a technical connotation to it than just the number of rows on disk. They are essentially the same thing. They are the same thing. It's just how we discuss them. When you get to SQL Server, this is always fun to me. So in Postgres, when you get to SQL Server, we have square brackets to qualify textual items like tables and so forth, particularly when they have spaces, just when we want to make sure we're referring to the exact object. In Postgres, that is done with double quotes. And what's even more fun is in MySQL, I believe it's done with backtick marks. So no database does it the same. The interesting thing here is, again, for SQL Server, if you're coming over, double quotes refers to text. Well, text in Postgres is single quotes. And so double quotes are qualified objects within the database. And the reason you might need to understand this and know this in Postgres, we're going to talk about later, is that Postgres is a case-sensitive database. You cannot, as far as I have been able to find, do a case-insensitive collation. It is handled by the collation settings of the actual operating systems. And it turns out that the ones that are available in most operating systems are not case insensitive. They're case sensitive because they have to be language-based collations. And so Postgres will actually coalesce everything to lowercase, which I'm going to show you in a little bit. But that is why you may need double quotes, and double quotes are only for objects, not for text. And then I put this in here because it's very similar. How do you get lots of data into Postgres quickly? Now, there's time has evolved. I actually, whether you do bulk insert or the row set inserts, whatever that might look like for you, the way you do it in Postgres is through this command or this program called copy. It's a part of Postgres, and it has actually been around since before the current thing that we would call Postgres that started in 1995 out of the research project at Berkeley in the 80s and 90s. And so copy is not a SQL standard. It's specific to Postgres. And there's a lot of development over these 30 plus years in taking rows of data, efficiently getting them into table. There are a lot of nuances about how copy works versus something like, in this case, bulk insert. But just to know, when you are looking at a big CSV file and you want to know how to get that into Postgres quickly, copy is where you're going to go. Now, whether you do it at the server level, almost every SDK that I know of that you would be using, whether it's in .NET or elsewhere, has a binary version of copy that you can use through your programming language if you were to read a file or a stream of data. And then there's things like pSQL, which is the command line tool for Postgres that also has a way of taking that data, reading it, and streaming it through copy into Postgres. So copy is really where it's at. You'll see it used anywhere Postgres is mentioned or hosted, something to get used to. And the last unique thing to talk about is this idea of toast. You will hear toast described all over the place within Postgres. And it's a really important part of how we manage data in Postgres, and it's been around for quite a long time. It stands for the oversized attribute storage technique. And whether you think of toast for breakfast or toast with a glass of champagne, you could go either direction with that. What this really looks like is lob storage to SQL Server. So when a row of data or a column of data can't fit on disk, it is, there's a pointer is added on disk, taken to data pages or storage off of the table pages, and compressed. There's a lot of ways that we can do compression with that. More and more abilities have been added over time to make Toast a very efficient place to store that large data. And it's just done automatically for you based on data type, based on storage, and so forth. Again, when you talk about extensions, this is also an area where a number of databases like Timescale have been able to take that Toast area and do things like really unique array compression to dramatically reduce the storage size on disk of data that can benefit from some kind of linear compression. And so there's a lot to learn here or understand about Toast, but it's a really integral part of how Postgres handles large objects and large chunks of data. All right, section 3 is architecture. And this is probably where everyone starts to get a little bit, this feels so different. Why is this different than SQL Server? So Postgres is a heap-based relational database with multi-version concurrency control. Now, all current major relational databases do some form of MVCC. There's been a significant uptick in discussion about MVCC just in the last month or two around Postgres and MySQL and some others. SQL Server also does a form of multi-version concurrency control to deal with transaction isolation. The difference here is that Postgres is heap-based. It is always heap-based. There's no such thing as a clustered index. Everything is done as a heap, and that has both benefit and it has some repercussions as you move towards understanding how data is stored on disk, what that might mean to some of your settings. In fact, right now I'm writing a blog post for my personal blog, which probably go up today or tomorrow, talking about one of those implications, which is table bloat, which is inevitable depending on how effectively you've set up your database. And so, check out the blog in a day or two, and we'll write more about that on Simple Talk and other places as well. But again, just coming from SQL Server, it was a surprise to me how it works on table and what that means to how my data is being manipulated. So Postgres supports 3 of the 4 transaction isolation levels that we talk about within a relational ACID database. Read committed is the default. You can do repeatable reads and serializable reads. And then read uncommitted, which essentially is no lock within SQL Server, is actually not supported. Now, because it is a SQL ANSI standard as far as relational ACID compliance, the 4 methods of isolation goes, it's just a no-op in SQL Server. So you can actually set the isolation level to read uncommitted, but you'll simply get read committed. And the team simply said 20, 30 years ago, read uncommitted just doesn't make sense in the form of this kind of relational ACID database. And so we are simply just going to choose not to jump through all the hoops to make something supported that we just don't feel is really necessary within an ACID area. Now, that's my interpretation. That's not exactly what they've said. Just to know that, I don't know if anyone would really be using read uncommitted in this context, but that's what happens. At a glance, MVCC as implemented, and really across all databases, the concept is that readers don't block writers. That means in Postgres specific terms, we do it uniquely in that all of the data that is currently being changed is all stored within table, not somewhere in a different part of the database. So in SQL Server, for instance, when you modify a row of data, if I have opened a transaction, and while my transaction is running, you modify a row of data. The changes are stored off disk, I believe in tempdb. And then as my transaction continues to run, I have access to that old chunk of data, and it will merge as it's being queried. There's a lot that happens behind the scenes. In Postgres, if that row is updated, every single new modification is always a new row, and it's a new row on disk in the table. And then we control which rows are visible to which transactions based on some hidden columns. And then when those rows are no longer needed by any currently living or running transaction, they can be cleaned up and that disk space provided back to the system. Now, there's a lot of things that have happened. Updates always create new rows. Because we're heap-based, normally that would go at the end of the table. But if there's space on page, for instance, we will now work since Postgres 11 to insert the new row back to the same page, so we're not growing the table larger than need be. So there's a lot that happens here, but it's just something to understand. Again, one of the reasons I'm writing that blog post even just now is every update, every insert, every update creates a new version of the row, regardless of what's modified. Even one value in a column will create an entirely new row so that we can do really easy transaction isolation. There's a lot of benefit in how it works, but it can have some repercussions, and that's what more work is being done every day on making that as efficient as possible within Postgres. Really, the seminal talk in MVCC given by a gentleman named Bruce Momjam is linked here. Bruce is actually going to be at Past Summit this year giving a talk about indexes and maybe some other things. Bruce has been a part of the Postgres project since 1995, 96. So he has really helped and really grown with the project over almost 30 years. And I've already said that. I forgot that I did this in the slide. So again, updates always create new rows. It's just something to understand within Postgres and what that might mean, particularly in how it works and how it runs. Really quickly, how to get connected. I think there are 2 slides here, and it's simply because it's one of those things that can be challenging. We are so used to SSMS, or in the more modern times, maybe Azure Data Studio. And even though other tools will connect to SQL Server, most of us have just grown to know and love because there's a lot of power in those tools because they're provided by the developer of SQL Server. That doesn't exist within Postgres. Now, there is pgadmin that is provided by a company or maintained by a company that is heavily invested within Postgres, EDB. Now, there are reasons, personally, I don't use pgadmin. It's just not my choice. It doesn't mean it's not a good choice. It's not my specific choice. But I originally kind of shied away from pSQL, which is the command line tool within SQL Server, within Postgres. And I shied away from it because, well, I was so used to using a GUI tool. Even though I'm comfortable with the command line, it just felt difficult. I would say over the last 5.5, almost 6 years that I have been back with Postgres, I have come to love pSQL. It is cross-platform, available on anywhere you would go. It is used in almost every blog post and every demonstration at some level when you're talking about Postgres. And so my bottom line is I believe you really should begin to learn it. I actually did a small I think a 2-part article on Simple Talk, the first link here, the Redgate short link, just talking about what it is, and then a whole bunch of ideas, just the common commands that I think you should learn first. Hopefully that's helpful, and just a good quick way to get started understanding pSQL, because it's a universal tool and there's a lot of power. It's been developed over almost 30 years by the core team to give you the information you need and make querying and managing Postgres really simple, or as simple as possible. So think about that. Some other tools. I personally use dbeaver in almost everything I do. It's a free open source tool. There is a paid version. For me specifically, in that realm, it's the closest to SSMS just in kind of how it's set up. Now, it is a Eclipse-based tool. I personally have never had an issue with it. There are former Eclipse-based, that's a Java-based tool, that I would never use again. Personally, dbeaver has never given me a problem across Mac and PC. You can obviously use Azure Data Studio. It does support Postgres. It has for more than 4, almost 5, probably about 5 years now. They do support notebooks in Postgres. There's some really interesting things there. Now, it's not the first-class citizen yet because SQL Server is still the primary goal, but it is a tool to use. A lot of people love DataGrip by JetBrains. It is a great tool, but it's a for-fee paid tool. If your company has licenses, I would absolutely say give it a try. There's a lot of great things that DataGrip will do. It's just not what I tend to use because of the license. And then there's a smattering of others. Now, I just threw a bunch of icons on here. I could probably put 40 or 50 other icons on here. One of the points to make here is that Postgres as a SQL alternative, as a SQL version, is really become the standard in how we connect to a database. Most tools will first and foremost say, we support Postgres, and that does hint at the nature of the popularity of Postgres and what's happening in the technology around us. So let's talk about a few configuration things. All right, so section 5. My main point here, I gave a bunch of links, and out of the gate here, I would say every non-serverless Postgres needs to be tuned, and I put that there for a reason. So many folks have transitioned to something like Amazon RDS, which is, maybe it's not an EC2-based solution. It feels like it's a fully managed solution, but it's not. It is the infrastructure is managed, but you still are responsible for ensuring that all of the settings are tuned for your workload. Now, they make a lot of really reasonable default configurations for you. This really hit me in my transition back to Postgres with the first company that I was using it for. We were a highly active, update-heavy IoT application. And we did not know, we assumed that more was being done in RDS than it was. And we had to work over a number of months to better understand the configuration of Postgres. And once we did, many things started to work significantly better. Now, things like Aurora, Azure Cosmos DB for Postgres, they are a little bit more automated. There are some things you cannot tune in those configurations and in those hosting options. But anything that is, you host and you maintain, and anything that is something like RDS, where it's infrastructure maintained, but you have to manage it, you really need to tune Postgres. You need to understand your workload. There's a couple of links I provided here, a couple good talks. It's really something you should go look at, really wherever you're at. Now, there are at least 4 settings I tell everyone about out of the gate. There are hundreds of settings, but coming from SQL Server, these are the 4 that you should consider. The first is shared buffers. All I will say about this is the going wisdom is 25%. Again, we have a number of articles that have been started on Simple Talk from one of the Postgres contributors and longtime Postgres community members. And unlike SQL Server, there is the buffer cache where your data is stored for easy read in memory. That is not dynamically handled by Postgres. You actually have to specify a chunk of memory that is reserved for your frequently queried data to be stored in memory. And so things like hit cache ratio actually matter a little bit more in Postgres because you have the control of that space. And then the rest of the memory is used for other things like query plan processing and so forth. So you really need to understand shared buffers, how to set that most effectively for your environment. If you are trying to make do with a very small VM with 1 or 2 or 4 gigabytes of RAM, and you're wondering why your 100 gigabyte database isn't performing well, it's probably because the data is just never able to stick in memory for more than a few minutes, and you just are going to have to upsize your database. There's really no way around that particular issue. Understand that. WorkMem is the unique thing to Postgres that again, we have more control over than in SQL Server. In SQL Server, when you run that query, it will plan the query and estimate how much memory it believes it needs to execute that query. If it estimates, a terabyte of memory and you don't have that query might never run because it's waiting for memory to become available. In Postgres will plan the query and then it will start to try and run it. And WorkMem is the amount of memory available to each node of the query plan that does some kind of data gathering, data merging, ordering, and so forth. And so if you have a very complex query with lots of orders and joins and merges, it can take that many operations times work mem worth of memory. And so if you have thousands of queries running and they all are using lots of RAM because it's a very complex query, you very quickly can use up the memory in your server, and even sometimes it's something like an out of memory error. Now, much of that has been mitigated in a lot of unique ways over the last couple of years with Postgres. But again, work mem is really, if things like sort operations are slow and they are being spilled to disk, work mem is what allows the server to have enough memory to do that sorting in memory rather than on disk. And then maintenance work mem, I talked about table bloat and that idea of new rows always being created. The server needs to have enough memory every time it spins up this maintenance task to free up those rows that are no longer needed by any transactions. So again, things like creating indexes, things like vacuuming the tables to make sure they're as clean as possible. If those processes don't have enough memory, they'll work slowly, and it just won't be as performant as it could be, and it will actually, over time, probably hurt your experience with Postgres. And so again, something you need to think about. And last but not least is max connections. It's exactly what it says. The unique thing here is that Postgres actually forks an individual process per connection. And so simply setting it to 10,000 connections because we think there might be some kind of pooling going on, that's not how it works in Postgres. And so you do need to understand how many connections your application generally needs, use some kind of connection pooler within your application or fronting Postgres, and just keep an eye on it. Those are things that you can watch for. How do you see these settings? Now, if you're using a hosted database, you probably will see it in an area like a console that you're using. You can always say show. This will display the current value. So show all will display everything. Show shared buffers will show you the current shared buffer setting for your connection. And then for those that you can set through SQL, you can say set and then the value. Now, not everything can be done that way, but there are a number of options that are valuable when you do querying to actually set that information. Now, I've mentioned vacuuming. And so I'm going to spend 2 or 3 slides here just quickly talking about what vacuuming is. So as I said, Postgres is an MVCC-based heap-based database. The way that we deal with transaction isolation is that every row contains the transaction IDs that can see that row. And so if I'm in the process of running a transaction and a row is modified, I am still seeing my version of the rows, not the new version of the rows. When my version becomes outdated and nobody needs access to it, that data needs to be freed up. We do that through a process called vacuum. It is so essential that Postgres has had for a long time this automated daemon that runs in the background called auto vacuum and actually auto analyze. And it runs very similar to statistics in SQL Server. So SQL Server, the statistics are updated based on the number of rows in the table. Starting with SQL Server 2016, that became more dynamic. Before that, you could set a trace flag. Out of the box, Postgres is set to 20% of the rows to update the vacuum and 10% to update statistics with analyzed. Now, on a table that's 10,000 rows, it's probably fine. But 20% of 1 million or 10 million or 100 million rows, if you wait to 2 million, 20 million, 200 million, you are going to run out of space probably before vacuum kicks in. And it's just inefficient. So you can actually tweak this per table. You can set different auto vacuum and auto analyze values for update heavy tables, for instance. So they're vacuumed more frequently, your statistics are kept up to date more frequently, and your application will just run better. It's pretty easy to do. You can simply set the alter table and set the factors that you need. There's a lot of documentation around this, things that you'll need to know. And again, I'm talking about some of this in this blog post I'm writing right now because it's come up so many times recently. My big statement here is if you think the auto vacuum and auto analyze is running too frequently, it's probably not enough. What we see happen often is that folks will go to a place like RDS and they'll see this thing called auto vacuum or vacuum running, and it seems to always be at the top of the top queries or most run queries. And they think, well, if that's running the most and that's not one of my queries, I should tune that down or turn it off. That's actually the exact opposite. Most of the time, vacuum should be very quick. It does run frequently to keep tables updated and ready for new data. And so just be very wary of that when your gut feeling might be turn it off or slow it down. It's particularly on update heavy tables. That is probably the worst thing to do. And think about tuning your maintenance work mem setting. Maybe it just needs to run a little bit more quickly because it needs a little bit more memory, something like that. All right, just a couple more sections. We are on a roll. Extensions I've talked about a few times. They're a really powerful feature of Postgres. The main thing I simply want to add here is 2 points. Number one, particularly for a database as a service, hosting service, wherever you might be, not every extension will be supported in every hosted environment. AWS, Azure, Google, DigitalOcean, wherever that might be, Ivan and so forth, all of them are going to support some level of extensions. There are hundreds to thousands of extensions for Postgres, but there are finite lists. Some of that comes to security. Once you get into a combined hosted environment, some extensions might not be as secure when you don't own the single server. So just recognize that. And then also recognize that extensions are installed per database. So even if you host your own Postgres server, if you have more than one database, you actually have to make sure that every one of those databases has the extensions you want to be installed. This is how you install them. You can see what is available within your hosted environment. You create the extensions, what installs them, and then you can update them over time. Backup, creation and backup, 3 quick slides just to talk to you about what this looks like. And I do this because almost everyone I know that comes from specifically SQL Server does get caught in this specific area. And so the first is just what the default database is. It is generally called Postgres. There's a reason for that. It's how the server is initiated. Some terminology for you to understand. The template, there are a couple template databases. Template 1 is kind of like the model database. So if you want a certain set of extensions or users to exist in every Postgres database you create, you can do that within the template 1 database. And then every time you say create database, it will use template 1 and you'll get all of that stuff. Now you can make your own templates and you can do some of those things, but just so you know that they are there, that's how that works. Backup, now there are a couple ways to do backups. PG base backup is actually a point in time to file system level backup. This is what's used when you do some kind of replication. You do a base backup to another server that copies all of the files necessary to restore and move on as a full copy. And then you can do replication and some other things. Most people, when you're just doing stuff internally, you want a copy that you can play with. PG dump is what you will see used. That is a way to do backups, a transactionally safe backups at a point in time. This is not a tool for doing your backup strategy. This is a tool for getting a backup that you can restore somewhere else, maybe for development or something of that nature. There's a number of ways that it works, either text-based, there can be some binary archive-based stuff, and there's a lot of functionality in PG dump and elsewhere. Here's a quick example of how you might dump a database to a file system using, in this case, the directory structure, which allows it to be parallelized. The one thing I did forget to put here is that the command, when you do a backup with PG dump, it will actually record that there is an extension in your database. So for instance, I say timescale a lot because it's where I used to work. The extension timescale is in that database, but it won't record the version. So what is replayed back is a create extension command to set up the database. And so when you take a PG dump and you take it to another server, and you restore a database with that dump, if that server doesn't have the same version of the extension, you might have some compatibility issues. That's one thing that's been in discussion for a number of years. How do we make that easier, make sure that things are working correctly? It's something for you to know. Then last but not least, the biggest thing is just how to restore. And most people that experience this, and I have done it many times with Postgres, is it's not quite like we're used to with SSMS. We can take a back file and we can simply say, hey, create a new database using this back file, and SSMS SQL Server is happy to do it, or through the command line. In Postgres, you always have to restore to an existing database. And so it looks like there is an option called create, it looks like that would create a new database for you. That's not actually what happens. So just to recognize that generally, the best practice is create an empty database, and then as part of the PG restore command, use that as your destination, and then it recognizes there's nothing in that database, and it will move forward, and the schema will be created, and so forth. A lot of other things around that, but I always just want to mention that on this restore slide because I've seen that trip up many, many people over the years. All right, now let's blaze through. We are actually nearing the end. This is going to be a couple quick hits. Again, things now that we're in the nitty-gritty of doing SQL, and we have about 15 minutes left, so we're really on track here, which is great. Just things that are unique and different to recognize. So array type or data types, there's a lot that is just different in how we approach it. There's an actual Boolean type, not just a bit. We have text. We don't have varchar or nvarchar or what have you. So we use text. Now they do exist. I shouldn't say they don't exist. There's really no value in using varchar over text. Space-wise, it doesn't take any more space. It's just the predominant. It's the way that it keeps things consistent. So just use text. A few other things down through here. We have an array type. I love the array type. It's really interesting. We have things like range types as well. And so ways that you can query and index that data. Again, you can index arrays of data within a data field. For some use cases, it's really, really powerful and really neat. I've mentioned this before. The case rules are really unique. It's a case-sensitive database. And so in Postgres, if you don't put double quotes around object names, everything is coalesced to lowercase before it goes to the server. And so you actually need to think that through. Again, I've taken or helped to take an application that was based on SQL Server to Postgres. And if you just use Entity Framework, for instance, it will often end up trying to take your camel case tables over, and then you have to double quote everything all the time for the rest of your life. That can be really frustrating. And so most people will go through the effort to transition their queries and their systems to use what we call lower snake case. So instead of camel case, we separate words by an underscore. And that is pretty much the standard within the Postgres community. As an example, if I were taking this directly from SQL Server to Postgres, I would have to double quote those names, or I could transition this to all lowercase and use the underscore. Limit and top. All of us have used top something to get just a few rows of data. In Postgres and MySQL and others, we use the limit at the end of your query. I mentioned group by simply to show you that in this case, Postgres, the way that queries are parameterized before they're executed, you can actually use aliases both in the group by and the order by. So you don't have to, in SQL Server, I believe still till today, even SQL Server 2022, group bys don't allow aliases. You can do that in order by, but not in both. That's why I show this. Doing date math. We are used to, or doing dates. We're used to saying year and month and day as a function. In Postgres, we have date part. So if you want to do something analogous to that, you would say date part in the year, date part month, and so forth. How do you get the current date? Well, we're used to select get date. In Postgres, there's select now, there's select current timestamp. They're all essentially the same thing. You can also cast them to time zone aware versions and so forth. And then date math is actually really simple once you understand what happens. So again, in SQL Server, we would do something like, here's a date is greater than, and then we would do some kind of date math, date add, or what have you. In Postgres, we have this data type called an interval. And so you can simply, as long as the data types match or can be coalesced to one another, can be converted, you can simply say timestamp minus some interval or date minus some interval, and that gets you a new date or timestamp to compare against. This took me a little bit of time to find when I first came to Postgres. Most of us over the years have learned the value and the power of an apply command within T-SQL, SQL Server. And so to do something like an apply, which runs the outer query, every row of the outer query, in this case from vendor, will be executed, the inner query will be executed. This is a great way to get the greatest of, the top one value of some maybe time series data, the most recent time. In Postgres, we do a lateral apply. So analogous to be something like an inner join lateral. There are other ways to do laterals, but that is probably the most predominant, is just doing a lateral join to the next table. And that gets you essentially the same thing. And then really the last thing I tend to show is inline SQL. We are so used to this, and I put this up often. You can write this anywhere in any T-SQL script, declare a variable, use the variable, print the variable, and everything just works. And the reason that works is that in SQL Server, you're actually running T-SQL, not SQL. In Postgres, unless you specify a language, everything is interpreted essentially as plain SQL. It's not a procedural language. So you actually need to create what we call an inline code block or a do block, or often referred to as an anonymous code block, and declare the language or just SQL in order to move ahead. So something to know, this messed me up more than I would like to admit for a number of things over the years. I'm going to breeze through these just as we're getting close to time. There's one last thing I want to show you. There are a number of differences. Probably the biggest thing that I talk about with functions and stored procedures in Postgres is, number one, you have a lot more flexibility over the language you can use, again, dependent on your hosted provider or what you've set up, but also that you can actually set some of the parameters around how the cost settings of, in this case, functions. So in SQL Server, we can't tune the cost settings of a function. In Postgres, you can actually, as you create or modify that function, you can say, hey, planner, when you run this function, assume it has a cost of X, or it has an output row count of X. And so you can modify how the planner runs. And that can be done in both. Stored procedures were made available in Postgres 11. One of the unique things that I do is you can actually commit within a stored procedure through a loop. So you can actually commit stuff as it goes. And it will not be rolled back if something later rolls back. That is sub-transactions. There's pros and cons to it, but it is possible and really helpful in some data processing things. Triggers, no one shies away from triggers in Postgres generally, I mean, with good cause. The unique thing here is that triggers are actually functions that are applied as a trigger. And so one of the cool things with that is you could have one trigger function that is applied to multiple tables. And so you only have to update one area of code, not multiple insert triggers and multiple delete triggers and so forth. So it's a unique way of doing it. It can also be, triggers also function either on a set or per row. There's a lot of flexibility in triggers, and that allows actually a lot of unique use cases, some of which are still very, very highly performant. You don't have to shy away from it. So we create a function body, and then we apply that function to the table, but we could just reuse that function for multiple tables if we wanted. And then last but not least is query tuning. So in Postgres, you explain a plan, and you can explain, and that would be like an estimated plan. It doesn't actually execute the query. Explain, analyze, actually present to you the exact query, the query plan for the query once it's executed. You can add parameters to explain, so analyze and buffers and so forth. Now, buffers is maybe being close to, with Postgres 16, might be enabled by default or have the ability to be enabled by default. This is like statistics IO in SQL Server. And so knowing how many pages of data, buffers is like pages, are modified or used to generate this query, the result is really, really helpful. When you have a slow query, it simply could be there's been lots of loops with millions of pages of data being looked at. So buffers, always use buffers when you do an explain plan. It is what we call an inverted tree representation. And what that mostly means is that we have nodes. They're denoted by this double dash arrow. And you read them from the inside out. As you look at the plan, which I'm going to show you in this next screen, the arrows that are furthest into the right are the nodes that are executed first. Now, there can be nodes executed in parallel, but within each parallel group, the nodes that are the furthest in are executed. And so we would take something like this and we would say, some things to point out. How many rows were estimated? That's the first parenthetical set. And how many actually came out? And so that's a good way to look at actual versus estimated. If it estimated 1 million and it only pulled out 10, statistics are probably out of date. How many buffers were read from disk? These are 8K pages. What kind of sort method was this? Did it happen in memory, or does it say external sort or external merge, which means it's sorted in memory, it's sorted on disk, which probably means you need more work mem for this query to work. Sequence scan is reading all rows from the table. It's a table scan. And then how much time was planned and how long it took to execute. So there's a lot there. There's some really great talks online about how to read an execution plan. The last thing I'm going to talk about is 3 slides here. It's PG stat statement is a must-have extension. Now, there are a number of these stat views within Postgres. PG stat statement actually it's an extension. It actually has to be installed into your database. Most software vendor and most vendors of database services like AWS now install this by default. You don't have to do it. And it's an easy way to see per query all of the work that's being done, buffers that are read, the CPU time if they provide it, things like execution time, number of executions. And then you can get a lot of value out of that to see. Now, statistics are not cumulative. That's the one drawback of PG stats. They are cumulative. That's the one drawback of PG stat statement. So until they are reset, which happens at server restart or happens if you are able to trigger as an admin user, they're just cumulative over time. So there's no way to look at the statistics and say, is this the bad query? And so don't hesitate to use third-party tools. There are a number of them. Obviously, Redgate is beginning down this path as well. Many of us have used SQL Monitor for our SQL Server estates. And so we're now doing the same thing with Postgres, and many of these things. We're giving you ways to look at query plans. We're tracking things like, sampling PG stat statements frequently so that we can show you time series of how each statement was performing over time and so forth. And, whatever those things might be, number of connections, what's your hit cache ratio, a number of ways to really investigate what's happening within Postgres. And so those are the top heavy hitting 10 things, areas of Postgres and SQL Server that are unique and different. So I'm going to see, there are a couple questions, and I'm going to quickly, as I go through, just show you where we're going with this series. So the first is the next one would be on June 22nd for the non-APAC region. Please feel free to sign up. We'll talk about Postgres getting connected and installed. We are doing more. We keep talking about Past Summit. It is in person this year, again in Seattle. It is in November. Early bird pricing ends on June 7th, so you have a couple more weeks. We are actually providing more Postgres content this year. And so the first is a pre-con specifically led by Ryan Lambert. It's going to be about PostGIS, which is geospatial data within Postgres. It's really unique. And Ryan is actually a SQL Server DBA by day and a PostGIS Postgres person by night. He loves Postgres and PostGIS. Really great teacher. I would encourage you to check it out. Grant and I will be doing an all-day session on SQL Monitor as well on Tuesday as a pre-con. And then we are actually we will have probably 10 to 15 Postgres sessions throughout Summit. We have set up this learning pathway. It's already been published. 3 or 4 of the people on this learning pathway have been involved with Postgres for 20 to 30 years. And so it's a great opportunity to come and talk to the folks that have been doing a lot of Postgres work. So questions, we have 2. So we'll get through as many as we can, and then feel free to reach out and we can do some others. What are some common issues you've seen with Azure Database and Postgres Flexible Server? I'll be honest, I haven't specifically used Flexible Server. I know the team at Citus fairly well, a number of the folks there. So Citus itself, it's a matter of just understanding what happens under the covers in the way that the data is scaled horizontally. You have to be really intentional, and they've done a great job in documentation talking about how to choose the keys for the partitioning and the horizontal scaling. I would, maybe it's a conversation we can have at some other point, and maybe get the Citus team involved in some way, but it's a really good team over there. Any suggestions? So the question is, do you have any suggestions migrating a whole server from SQL Server to Postgres or vice versa? Something that can handle all these changes in configuration code changes. I don't know of anything that will do all of the configuration changes. AWS has put a lot of effort into their migration service that will get you from one to the other. But that would be a first place to start. There are a couple of consultancies within the Postgres space that have a lot of experience doing that. Reach out. We can talk about what some of those are. But really, AWS, Azure, they all have teams that are really skilled at helping you understand a pathway forward. I'm sorry I can't be more specific there, but I think it's a way, at least forward for your code in your database. Configuration is going to take something over time. Having something to monitor what's going on, and then reaching out to the monitoring company, even if that's Redgate, hopefully, that we can help you understand what some of those things mean. Would you choose, 2 more that I think we can get through here, would you choose Cosmos PostgreSQL or Azure DB for Postgres? So Cosmos is the serverless. That is Citus, horizontally scalable. Azure DB for Postgres is kind of like RDS. It's the VM-based version. It depends how much control you want. With the EC2, or that's not EC2, the VM-based one in Azure, you're going to have a little bit more hands-on experience of just what's going on and how to configure it. Both are really viable options depending on what you need. And then last, great question. Sorry I didn't cover this. Is there something similar to a CTE in Postgres? Absolutely. A CTE or recursive CTE, that's a SQL standard. And Postgres, among all of the databases, probably supports more SQL standard compliant commands than any database. And so absolutely, CTEs work. They do work a little bit differently as far as what's materialized and what's not. But you can start to move forward there, and some really good documentation otherwise. Thank you for sticking with me. I told you at the beginning this was going to be fast. There's a lot of content. My goal is that there's something here that you will be able to reflect back on and know that you can go forward and find the information you need now. The rest of the sessions probably won't be as packed, but it's hard when I have attention for 1 hour. I just want to say these are all the things that have tripped me up over the years, and hopefully that helps you in the future. It's been a pleasure. I hope you've had it's been a formative session for you. And we look forward to seeing you next month for the third PG 101 with Redgate. Have a great day. Take care.